Hello everybody, I am Suman Matthews and today we will be discussing the next of my videos on straight lines, that is equation of a line part 2. The last video was equation of a line part 1. Here we will be discussing some more problems on how to calculate the equation of a line. This is useful for students who have grade 10 maths and grade 11 maths, and also students preparing for the GRE quantitative section and the SATs and the ACT. Write the coordinates of the orthocenter of the triangle whose sides lie along the lines x equal to 0, y equal to 0 and 3x minus 5y plus 7 equal to 0. This is the line x equal to 0, this is y equal to 0, and this is 3x minus 5y plus 7 equal to 0. Now orthocenter is the point of intersection of the altitudes, and in this case for a right angle triangle the orthocenter will be at the right angle. So the orthocenter is 0, 0. Question 2. Reduce the following equation to the slope-intercept form. Also find the slope and y-intercept. We have 6x plus 3y plus 5 equal to 0. So we write it as 3y equal to minus 6x minus 5, or y equal to divide by 3 minus 2x minus 5 by 3. This is of the form y equal to mx plus c. So your slope is minus 2 and your y-intercept is c, which is minus 5 by 3. Question 3. A line passes through 2, 2 and it is perpendicular to 3x plus y equal to 3. Find its y-intercept. Y equal to minus 3x plus 3, so slope is minus 3. So slope of the required line is 1 by 3. So equation of the line will be y minus 2 equal to 1 by 3 into x minus 2. Cross multiplying you get 3y minus 6 equal to x minus 2 or 3y minus x equal to 4. We need to calculate the y-intercept. To find the y-intercept, put x equal to 0. So y is 4 by 3. So your y-intercept is 4 by 3. Question 4. Find the equation of a line parallel to x minus 3y plus 5 equal to 0 and with y-intercept 5. So 3y equal to x plus 5, converting it to the form y equal to mx plus c, you get y equal to 1 by 3x plus 5 by 3. So your slope is 1 by 3 and the line passes through 0, 5. So equation of the line will be y minus y1, that is y minus 5 equal to m, which is 1 by 3 into x minus x1, that is x minus 0. So I get 3y minus 15 equal to x, which is the equation of the line, or 3y minus x plus 15 equal to 0. Question 5. In what ratio is the line segment joining 1, 3 and 2, 7 divided by 3x plus y minus 9 equal to 0? So let this line 3x plus y minus 9 equal to 0 divide the line segment joining 1, 3 and 2, 7 in the ratio m is to n. So I have 1, 3 and 2, 7 and this is the line. So if p is the coordinates of the point, using section formula, p will have coordinates 2m plus n by m plus n or 7m plus 3n by m plus n, and substituting the coordinates of p in the equation of the line, I get 3 into 2m plus n by m plus n plus 7m plus 3n by m plus n minus 9 equal to 0. So I have 6m plus 3n plus 7m plus 3n minus 9m minus 9n equal to 0, taking the LCM. So 4m minus 3n equal to 0, 4m equal to 3n or m by n is 3 by 4. So the line segment is divided in the ratio 3:4 internally. Question 6. Find k so that the three lines 2x plus y minus 3 equal to 0, kx plus y minus 3 equal to 0, 3x minus y minus 2 equal to 0 are concurrent. Three lines are said to be concurrent if they intersect at a point. So we take 2x plus y minus 3 equal to 0 and 3x minus y minus 2 equal to 0 and solve it simultaneously. Adding, we get 5x equal to 5, so x equal to 1. Substituting in one of these equations, you get y equal to 1. So point of intersection is 1, 1. Substitute that in the line 3x minus y minus 5x plus ky minus 3 equal to 0. So I get k equal to minus 2. Question 7. Find the coordinates of the orthocenter of the triangle whose vertices are 1, 2, 3, minus 4 and 5, minus 6. Now here, as I said in an earlier problem, orthocenter is the point of intersection of the altitudes. So let h1 and h2 be the altitudes. Now slope of BC will be minus 6 plus 4 by 5 minus 3, which is minus 2 by 2, which is minus 1. So slope of h1 is 1 and h1 passes through 1, 2. So equation of h1 will be y minus 2 equal to 1 into x minus 1 or y minus x equal to 1. Slope of AC will be minus 6 minus 2 by 5 minus 1, which is minus 8 by 4, which is minus 2, and H2 passes through 3 minus 4. So equation of slope of H2 will be half since it's perpendicular to AC. Equation of H2 will be y plus 4 equal to half into x minus 3. So I get 2y plus 8 equal to x minus 3 or 2y minus x equal to minus 11. Solving both the equations h1 and h2 simultaneously, we have 2y minus x equal to minus 11 and y minus x equal to 1. Adding both, we get y equal to minus 12. Substituting in one of the equations for y, we get x equal to y minus 1, that is minus 12 minus 1 is minus 13. So your orthocenter is minus 12 minus 13. For more videos, subscribe to my channel MathMadeEasy.